All right, howdy folks, happy Friday. Let's get into it. These are the notes for area of triangles. You have one warm-up problem, so don't not do it. Take a moment, pause right now. All right, I am assuming that you have paused and now unpaused. So we're gonna push forward with the solution. All right, let's do this so you can check your work, make sure that you got the skills. All right, determine the perimeter and area of the parallelogram below. So in order for us to find the perimeter, we actually don't need to deal with that 60 degrees. We don't need that for the perimeter because we know that in a parallelogram, the opposite sides are congruent. So our perimeter is 4 plus 8 plus 4 plus 8 is 24. Include the units, feet. All right, perimeter is 24 feet. If we're going to talk about area, though, we need to find the height, because the height of this parallelogram is not 4, right? That is one of the side lengths. So if we say that the base is 8, then we would need to find the height of the parallelogram, and we can do that by drawing in an altitude from one of the vertices. Right, so now we have a right triangle. We know that one of the angles is 60 degrees. That means that this is a 30, 60, 90 right triangle. And so because in our 30, 60, 90, following the 1√3 ratio, because we have the 4 feet across from our 90-degree angle, that means that we have 2 and 2√3 in our 30 and 60. Right, so across from the 60, 2√3, which is our height. And the total area, which is equal to base times height, total area of our parallelogram is 8 times 2√3. The area is equal to 16√3. All right, let's push forward onto our notes down here. All right, notice that we have 3 triangles here. We have an acute triangle on the left, an obtuse triangle in the center, and a right triangle on the right. For each of these triangles, we have the same dimensions. We have 5 centimeters, 12 centimeters. 5 centimeters, height of 12 centimeters, right? The altitude is 12 centimeters long. And again, 5 centimeters and an altitude of 12 centimeters. And so they all have the same dimensions, but the question is, do they have the same area, right? And you may know a formula for the area of a triangle, and so that might help answer this question for you. But we're just going to investigate a little bit and see where that formula comes from, and if that answers our question for us. All right, so I'm going to draw out the 3 segments of this triangle on the left, this acute triangle. And I'm going to duplicate 2 of those side lengths. And I'm going to translate them so that they meet at the vertices of the third side. Now, I'll pull that off, right? And what is it that you notice about what we've drawn? Right, what do you notice about what we've drawn here is the question. Hopefully you would notice that because we duplicated and didn't dilate in any way, that we've got 2 pairs of congruent sides, right, where this third side reflexively is congruent to itself. So what we have here then are 2 pairs of congruent triangles, right, by side, 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 and those 2 triangles together make a parallelogram because there are 2 pairs of opposite sides. So we could say, if we're talking about area, that the area of one parallelogram, parallelogram, I don't know, my spelling today, oh my goodness. Area of one parallelogram is equal to the area of 2 triangles. Right, and we can see that in our diagram there, that the one parallelogram is made up from 2 triangles. So if we just want to talk about the area of a single triangle, that means that we would have to divide by 2. Right, reduce, and that'll give us the area for a single triangle, right? The area of a single triangle is equal to half of the area of the parallelogram. But if we recall from yesterday, the area of a parallelogram is just base times height. So if we want half of that to get the area of our triangle, then we could say that the area of a triangle is equal to base times height over 2, or 1/2 base times height. So to wind it back, this triangle on the left has a base of 5 and a height of 12. So the area of this triangle is equal to 1/2 times the base times the height, which is going to be equal to 30. Right? In the center, we have a base of 5 and a height of 12. So the area is going to be equal to 1/2 times the base times the height. Same formula. Still equal to 30. And over on the right, the area of our triangle with the base of 5 and a height of 12 is 1/2 base times height. And as always, 1/2 times 5 times 12 is equal to 30. Right, so to answer the question, yes, they do have the same area, and that is because they are triangles, and the area of a triangle follows this formula. Base times height over 2. All right, now you've got a Go formative to get into, and once you're good with that, you are good for the day. Go ahead and send me emails if you have questions, and I'll try to answer them as best I can. I might hop on a call, get it sorted out, but have a good one, folks.